Hello everyone. On behalf of Team 128, I would like to present our project Box Office Oracle, an interactive tool designed to predict and explain a film's level of success using data and machine learning models. In an increasingly competitive film industry, need a system that can estimate box office revenue before release, while also identifying which factors most strongly influence a movie's success. This is exactly why our tool was created. As a data analyst, I see a major issue in today's market. Although many studies show that machine learning can accurately predict movie revenue, most existing models function as they produce strong predictions but fail to explain the reasons behind them. This limits their value for filmmakers, who must make decisions based on clear information and an understanding of both risks and opportunities. The biggest gap right now is between the predictive power of data science and the practical decision-making needs of film producers. Our project aims to close this gap by emphasizing model interpretability and providing intuitive, interactive ways to explore the data. To achieve the best possible prediction of box office revenue, we adopted a structured data analysis workflow. First, we experimented with multiple machine learning models, building and comparing several algorithms, including linear regression as our baseline, decision tree, random forest, XGBoost, and neural network. The goal of testing various models is to identify the optimal balance between predictive accuracy and interpretability. In this section, I present how our team collected and explored the data. We used the TMDB dataset from IMDb, which contains more than 434,000 movies with 29 features. The dataset is fairly large, about 680 megabytes, and has no duplicate records. However, some columns have relatively high missing rates, especially the genre column, which has around 18% missing value. In our initial analysis, we found that drama, documentary, and comedy are the three most common genres, reflecting global production trends. Descriptive statistics also show that, while a few films have extremely high revenues, the majority earn much less, indicating a highly skewed revenue distribution. The interactive dashboards built with Plotly helped us uncover several interesting patterns. The number of films produced increased steadily from the early 2000s and peaked in 2019. The United States is the largest film-producing country. During the model evaluation process, linear regression performed poorly, with an R-square of only 0.393, because the dataset contains many highly granular categorical variables. Models such as decision tree and random forest were not suitable, while the neural network yielded even worse performance, despite more than 4 hours of training time. In contrast, XGBoost produced the best results and trained quickly, allowing us to experiment with many different configurations. After optimizing the data processing pipeline and tuning the hyperparameters, the XGBoost model achieved an R-square of 0.791. The tuning process involved exploring a wide range of hyperparameters such as n-estimators. Once the model was optimized, the team tested several categorical encoding methods for SHAP analysis. However, ordinal encoder and target encoder reduced the model's accuracy. The most effective encoder was CatBoost encoder when placed inside the pipeline, enabling the model to achieve an R-square of 0.737, while still allowing SHAP values to be computed. This makes the model flexible for quickly testing hyperparameter changes and observing how each factor influences the prediction outcomes. In this study, our goal is to gain a deeper understanding of the factors that influence movie revenue, and to build a tool that helps producers and investors make better decisions. Throughout the analysis, we identified several important trends in the film industry, such as the dominance of English language films, the regional concentration of film production, and the large disparities in both budgets and revenues. When testing multiple machine learning models, XGBoost delivered the best performance with an R-square of 0.791. We found that data processing, especially for highly fragmented categorical variables, has a significant impact on model accuracy. When applying SHAP for model interpretation, CatBoost encoder proved to be the optimal choice, because it preserved accuracy, while providing real-time, intuitive, and interpretable explanations. Beyond revenue prediction, we also built actor and country network visualizations to offer deeper insights into relationships within the film industry. Finally, the entire system was integrated into an intuitive web application that allows users to view predictions, explore the data, and understand which factors have the greatest influence on movie revenue.